we have Shahir, who is a distinguished engineer and chief architect at IBM. His talk is on why and how to put Apache Ignite in the cloud and the 5 lessons we learned doing it. So without further ado, I'll hand it over to you and I'll give you you've got your slides. Over to you. Thank you.
Thanks, Stephen. And what a great start to the Ignite Summit Cloud Edition. To hear Nikita share, his vision for in-memory computing in the cloud was just awesome. The customers that I work with are all moving to cloud for various reasons. And the move to cloud requires legacy applications to be modernized. What I want to do this morning is share with you the key reasons why customers are moving to cloud. And I want to share our point of view on hybrid application modernization and the role that in-memory computing plays. And I'll also share with you some lessons learned running Ignite on the cloud. So my name is Shahir Daya, and I'm an IBM Distinguished Engineer and Chief Architect in IBM Consulting. So every large organization that I'm working with is undergoing a digital transformation. And it's all about the business outcomes. Okay, it's about the better quality, lower cost, better customer and employee satisfaction, improving customer retention, among very many other benefits. But to achieve these benefits, you actually have to modernize your applications. The legacy applications that you have today are basically inhibiting progress, are inhibiting being able to innovate quickly. And modernizing these applications is critical. So what exactly is modernization? So application modernization is about evolving an application's architecture. It's about looking at the deployment topology. It's about DevSecOps approaches. And it's for the existing state of your applications so that you can actually add new functionality and capabilities. And you want to be able to add that capability incrementally and obviously with high velocity. So large organizations that have been around for a while have applications that have been around for a while. In fact, some are many decades old. I mean, I've worked across many industries and I've seen core systems of record that are 30 years old, 40 years old. And in almost all cases, they've gathered a lot of technical debt over the years. And, they were built with architectural styles that were commonly used at that time. And many are batch oriented, right? Some years ago, I was the architect for the redesign of an online banking system for a large bank. And it was a large JEE monolithic application. And we used to have quarterly releases, right? And I mean, who does quarterly releases now, right? But we used to have quarterly releases. And, I remember we used to wake up at 2 a.m, right? And we'd all get on a conference bridge and we would start the process of deploying our new release. And what did we have? We had a spreadsheet. And this was no ordinary spreadsheet, right? This spreadsheet had 500 rows in it. And it had minute by minute what we were going to do and who was going to do it. And once we were done with that spreadsheet and the application was deployed, the new release was deployed, the stakeholders would come on the phone, right, at 6 a.m. to do some basic testing. And they do some testing, right, to make sure everything was good and that we could keep the release in production and we could all go to bed. And then someone would complain that, the shade of blue that you've used, that's not the right shade of blue, right? That color is wrong. It's not part of our branding. And we need to roll back, right? So all the bug fixes, all the new features, everything has to come back out. And what did we have? Yeah, you guessed it. Another spreadsheet. And again, 500 rows, right? In reverse order, right? So it used to be a nightmare, right? We need to break these monolithic applications down into some of the more modern architectural styles, whether it's microservices or something else, right? But we need to break these monolithic applications to microservices with their own source code repos, independent CI/CD pipelines, where teams can deploy their microservices on their own schedules, right? And these microservices can be scaled independently, right, depending on what their needs are. And if some microservices fails, at least it doesn't take the entire online banking system down, right? You get a degraded experience. Maybe some things fail, but other things are still working, right? The bottom line is that applications need to be modernized to be able to innovate and compete. And big bang modernization approaches fail. I mean, we've tried them, they just don't work, right? We need an incremental approach. We need an incremental approach that lets us innovate and get new groundbreaking, disruptive capabilities into the market, into the hands of our customers while we deal with our legacy systems of record. So the digital core pattern is our approach to hybrid application modernization. So when you look at what's on the screen here, you see the systems of record on the left-hand side. Large enterprises have many tens of systems of record, right? I'm working with a bank that probably has around 50 systems of record. And these systems of record, like I said, have been around for a while. And they're application silos. The data is locked up in these systems of record. And they are the rightful owners of the data. If you need to access that data, you want the source of truth of that data, you're going to go to that system of record. But the data is locked up. And a lot of these systems are batch oriented. And so for us to be able to modernize, for us to be able to innovate and create new experiences, it's extremely difficult. And one of the biggest challenges and cost drivers has been integration, right? So when we're creating a new customer experience and we need data, and typically we need data, it's read-only data. All we want is to present some data in a different way. And we're just reading data. And we have to integrate with maybe 4 or 5 different systems of record. And each of these systems of record have different integration mechanisms. Some of them might be on the mainframe, some might be Oracle-based, some might have SOAP-based web services, and so on. But the effort to integrate with these systems of record just to read data is a big cost driver and impacts our time to market. And how do we make these systems of record event-driven? We're interested in things happening in real time. We want clients to experience our capabilities, not in a batch way, but in a real-time way. So how do we make these systems of record more event-driven? Right. And so what this digital core pattern does is that we are instrumenting systems of record so that they can emit transactional events as they happen. And when an event happens, we're ingesting it into that event-driven book of reference in the middle, and that's Kafka. It could be other things. In my case, in many of my client cases, it's Kafka. And we're ingesting the data into a raw landing zone. So the data is coming in, it's streaming in, it's being emitted by these systems of record, and it's landing in Kafka topics in the raw landing zone. And once it's there, no one can access it in the raw landing zone. We're going to do some ingestion processing. We're going to convert the data, combine the data, convert it, and transform it to a unified data model that's hopefully aligned to the industry. Right. So if you're banking, you want to align to the banking industry architecture networks model. If you're in airlines, you've got your own data model and so on. But we align it to an industry aligned data model. And once it's streaming into the curated zone, anybody can tap into those streams and take real-time actions, right? Gain insights or create experiences as events are happening. The other thing we do from that curated zone, we project materialized views into an in-memory data grid. And those materialized views, on top of that is where we have our layer of APIs. And those APIs are what serve up that data in those materialized views to create channel experiences. So when you think about a channel experience, whether it's a mobile app, whether it's a web application, or it's a customer care, customer servicing type application, whatever it is, it's going to, at the end, it's going to hit an API that's going to want to read data, and it's going to get it straight from the in-memory data grid. And it's obviously speed, lower latency, and so on. So lots of advantages. So you can immediately see we're using the QCRS pattern here, where the reads and the writes have been separated. And getting the writes off of some of these legacy systems that have been around for so long really helps those systems. It alleviates a lot of load, and they can perform better, they're more reliable, and so on, because a lot of the workload that they've been taking has been read workloads, not writes. And so moving those reads across has significantly helped a lot of the systems of record. And the other important aspect here is once we have the curated zone, clients have come up with some very interesting use cases that they couldn't come up with before. So obviously, first and foremost is now they can actually do real-time use cases that are event-driven. And secondly, they've now got data from different systems of record that they can combine together and use it in very different contexts. And they couldn't do that before because the data was siloed, the applications were siloed. What we found out after the fact was that after launching a few products on this platform, and customers wanted to understand why these products were doing so well, and asked the data science and the analytics team to give them some insights, we found out that the curated zone was perfect to feed that data lake because the data was curated, it was aligned to an industry data model, it was coming in real time, and we could just sync it to a data lake. Then you could do your BI and analytics functions. We're also starting to see more and more the need for leveraging machine learning and so on. And having those kind of compute run right next to the data in that in-memory computing platform is something that is going to be really, really powerful when the data and the compute is right next to each other. The other aspect of this architecture is the metadata repository at the bottom. Because it is very, very data intensive, we're getting data from legacy applications and we're bringing it into this event-driven book of reference. We're ingesting it. Streaming applications are transforming it to a business-aligned data model. And then it's being consumed by streaming applications at the bottom and APIs at the top. We're creating materialized views, SQL tables from there. It's important to understand, where did the data come from? Which system of record? Who touched that data? What did they do to the data? Who's consuming the data? We'd had to answer a lot of those kinds of questions, whether it was from owners of the systems of record who came and said, hey, you took all my data. It's in your event-driven book of reference. You've got applications consuming it. What derivations of my data do you have? Who's consuming it? Right? The security team comes and says, okay, you guys have all of the data for all of the systems of record. What data do you have that's PII? Right? So data classification was important. So we needed to integrate a metadata repository that could give us the data lineage and also identify which fields were PII and so on. So we would know exactly a field, it could be a copybook of a mainframe application. We should be able to tell exactly where it is. Did it end up as a column in a SQL table and so on, and who's consuming it? What are the APIs consuming it? So that metadata repository was extremely important. It was integrated into this digital core solution. Now, this solution offers us 3 different patterns of modernization. One, as soon as the data's out, we can start creating experiences a lot faster, because to read the data, we just go to the in-memory data grid. We don't have to integrate with the systems of record. The other option is the strangler pattern that we've used quite successfully. We take what we call a vertical slice. The vertical slice it has got a bit of the experience. It's got the APIs. It's got the portion that's in the in-memory data grid. It's got the system of record. So we take a vertical slice from the legacy application and we strangle it out. And when we strangle it out, we're building it in the cloud, in microservices, in a modern way. And obviously, then you just have your typical router up front saying, if it's this particular product or capability that you're going after, then you need to go here. And if it's something else, then you go to the old. Right? So that's the normal strangler pattern. And this works really well with the strangler pattern. And the third thing that we've done successfully is core replacement. If you've got a core system of record and you want to not invest in it, you just want to replace it with another core, getting the data out, putting it in a unified data model that's aligned to the industry, and then having that data hydrate your new core works really well. And we've got times where we are coexisting an old core system and a new core system, feeding the exact same Kafka topics in the curated zone. And the experience layers above don't know which core system that data came from. Was it the old core or the new core? And they shouldn't know, and they don't really care. Okay, so these patterns work really, really well. Let me move to talk a little bit about cloud and how cloud's fitting into this story. So why put Apache Ignite on the cloud? Look, I find many customers don't even understand what it means to be cloud native, right? Cloud native applications take advantage of the cloud. You know, the on-demand provisioning of compute and storage, the elasticity of the cloud, the managed services that are available that you can take advantage of, you know, in minutes, right? That elastic scalability enables us to add new Ignite nodes very quickly, right? If you were doing this on premises, and we are, and many people are, if you're doing all of this on premises, your capacity planning would need to be very thorough, right? You need to have a very thorough exercise to know how much capacity are you going to need, what does the growth look like, when do you need to plan to order more hardware and add more hardware. You're going to figure all of those things out. When we're in the cloud, we can guess at things, and the consequences aren't that severe, right? The flexibility of cloud, enables us to pick the right shape for the machine, right? And when I say shape, I mean, the right CPU and the right memory based on the use case, right? If your use case is, a data grid type of a use case, you want to go higher on memory, right? So depending on your use case, you can pick the right machine shape. Now, look, to get something done on the cloud is much faster than trying to get it done on premises, right? Regardless, in a large organization. The one thing that frustrates me is when an organization acquires cloud and they have signed up with a cloud provider and they want to go cloud native, they want to transform, they want to change their organization to do things differently, and then they put a ticketing system in front of their cloud. So if you want anything, you got to open a ticket, and it's going to take 2 weeks for that to be provisioned for you, and that defeats the purpose, right? You're going to limit the benefits you can realize with the cloud if you do something like that, right? So things that you can do on the cloud, you can do things a lot faster on the cloud than on premises. So you can really, really achieve speed. So let me focus on a few lessons learned. Now, we have put Ignite, actually Gridgain, on Red Hat OpenShift, on IBM Cloud. We're working through several use cases. We've done this. We have internal applications at IBM that leverage Ignite. We've got applications we're building at customers or have built that are in production that leverage Ignite. And we're doing a lot of experimentation with IBM Cloud and Red Hat OpenShift on IBM Cloud. So my lessons learned are going to be focused around the experiences we have had running Ignite in OpenShift on IBM Cloud primarily. So firstly, leverage Kubernetes. And we found that Ignite and Gridgain, they work really well in containers. And Kubernetes makes things, you get a lot of things out of the box that you would have to take care of otherwise, right? So if when you have pods and you've got your probes, your liveliness and readiness probes, if something goes down, it can recognize it's gone down and restart it and so on, right? So there's a lot of advantages with leveraging Kubernetes and letting it orchestrate your containers. Now, consider the Gridgain and Ignite operator for Kubernetes. It could save you a lot of time. Now, you could also, go with Helm charts and so on, right? But leverage Kubernetes. I find that, we found Kubernetes to really help us out in terms of accelerating our path to getting Ignite onto the cloud. My second lesson is about automating everything. Now, this is a no-brainer. Look, you have to automate everything, right? Even when you go down the microservices path, right? And I have clients where we've taken a large monolithic application and ended up with, instead of having one thing that we have to deploy, usually there's more than one thing, just I'm trying to simplify the argument here. You have a large monolithic application that you have to deploy, it's JE. We've taken that and we broke it up into roughly 100 microservices. If it's one thing, if we were doing it manually, so what? We'd manage somehow, right? You shouldn't do it manually, but if you are, you'd still somehow manage. But if you have 100 microservices, how are you going to do that manually? You just can't. So you need automation. And with any application modernization, you're going to look at your DevOps and your DevSecOps, and you're going to automate things. You want that repeatability, right? And so treat the cloud resources as completely disposable, right? I could create things in the cloud, provision things in the cloud. I could delete it in the next minute and then recreate it exactly the same way as I left it, 2 minutes later. Right? So treat these things as disposable. You should have the automation, the scripting, or whatever it is to be able to reprovision and reproduce that environment very quickly. In terms of application deployments, you should absolutely be leveraging blue-green, zero downtime type of deployments. You don't want any outages on your applications. And a lot of this relies on the fact that you're treating these things as disposable, right? You have your application running, you have a new version, you deploy a new version right next to it, you flip the traffic over. When you're happy, then you can destroy the other one, right? Very similar types of approaches, right? So make sure absolutely everything is automated. Okay, know your use case. Look, there's so many things that Ignite can do, right? It's not just, an in-memory data grid, right? It's much more than that, right? So understand what your use case is and then size your Ignite environment accordingly, right? If you've got use cases that need more memory, then pick the right machine for that use case. If you are using persistent storage, with persistent storage, we found, you have to pick the fastest possible storage if you're going to use persistent storage, right? So if you're going to use persistence in your use case, use the fastest possible storage provider that cloud offers you. It's going to be important. We found that if a slow disk can really impact your use cases. And if you're going to do compute, figure out what your use case is, right? So we're working jointly with Gridgain on a use case around credit card fraud detection. And we've been having lots of discussions around, the credit card transactions streaming in, they're in Ignite, and we want to put the machine learning model right next to where the data is. And we want it to be fast, right? So you have to think through, what is the use case? What am I actually trying to do, right? In terms of performance, you absolutely have to performance test it. And you have to performance test the end-to-end scenario. I've got clients that are using, hybrid cloud. And you heard some of the comments Nikita made on that, right? We're putting portions of an end-to-end applications, could be in the cloud. There's other portions that could be in another SaaS provider. And there's other portions that could be on their premises in their own data center. Latency it's extremely important to understand what kind of latency you're going to be able to tolerate, right? And what exactly is the use case, right? Because that use case is going to determine how much latency and how it's used and so on. So you need to test the end-to-end setup and make sure it actually meets the requirements you have. And I'll give you an example. So for that digital core architecture where a transaction is happening on a core system on the mainframe, and it's emitting a transactional event, and I'm getting it from, let's say, MQ, then it's going to Kafka Connect and it's being ingested into a Kafka topic. And then I have some streaming apps that are processing it and transforming it into a unified data model. And then I have a sync connector that's syncing it into Ignite. And then I've got APIs that are consuming it. So from that end to end, because my digital core system is eventually consistent, transactions happening on the system of record, eventually it's ending up in a materialized view in Ignite. That end-to-end latency that we've been dealing with is around 250 milliseconds. 250 milliseconds for the read what you write problem. For some of the use cases, it's okay. But in many cases, you may need single-digit millisecond latency. So think about what your use case is. Make sure you performance test it. Performance test things early. And finally, probably one of the most important ones is pay attention to security. When you put things in the cloud, you really got to, double check everything from a security standpoint. And look, use Gridgain, use their security and auditing features, because you're going to need them, right? You want to make sure, node to node communication is secure. You want to use authentication and authorization. You need to make sure auditing is in place if you've got regulated type workloads, firewall ports and disk encryption. You have to look through all of this. Again, it's going to depend on your use case. It's going to depend on the kind of data you have that you're actually bringing into this platform. And have your security team or a third-party security team come and do an analysis, right? Whether you want to do a threat model or do an ethical hacking type of an exercise, it's worth having it done, and to make sure that all of the things that are important from a cloud standpoint have been taken care of from a security standpoint. With that, I want to say thank you, and thank you to the Ignite Summit team that's done a fabulous job with organizing this event, and the developer relations team at Gridgain that continuously just put out some amazing material that we leverage quite a bit in the work that we do in trying to get things working for our clients. And I know that there is a great day planned ahead, and I know that I'm going to learn many more lessons learned by listening to some of the talks that are coming up. My contact information is up there. Feel free to reach out to me. You can find me on LinkedIn. I have a presence on Medium, where I do publish some of the work that we're doing that involves Ignite and Gridgain. And with that, thank you so much for attending this talk.
Thank you very much for your talk. It's fascinating. I didn't see any questions coming through in the comments, but I had one question. So you're working with these kind of big customers, and you're doing this kind of cloud migration. Did you come across any kind of resistance to moving these kind of applications into the cloud? And how did you kind of resolve those kinds of conflicts?
Yeah, so Stephen, that's a really good question. So yeah, absolutely. There's a lot of resistance. There's clients that are going to be slow adopters, right? And I think it takes time for them to realize the benefits. And it's all about the business outcomes. What are the business outcomes? That's what they care about. And at the end of the day, if the business outcomes align, you can convince them to move things to the cloud. And when you look at the benefits, right, using a cloud native type environment, we're seeing, and customers are openly saying this, we're seeing time to market for a product being reduced by 50% because of cloud and because of the new ways of working with the cloud, right? And that's impressive, right? A product would take, typically a year to do, and they're doing it in 6 months. And time to market is so important for them to be able to compete. They're being cautious with their data, right? In many cases, we may have, the user experience and the APIs and everything running up in the cloud, maybe a little cache, but they'll eventually link back to their data on their premises. And that connectivity and that latency with that connectivity is usually the challenge that we are facing.
Yep, that's good to hear. I mean, all the stuff you're talking about, data lineage, was like a pain point that I've come across a number of times. So it's kind of good to hear that it's other people are experiencing that pain as well.
Yeah.
Sorry, a question just come up there. If the state of the business application is the critical path of a company achieving its business objective, is the CEO aware of business case? Does that correct the IT support that sees critical business function?
Yeah, so Gordon, I think that's a great question, and with all of the digital transformation work that I've been involved with at several clients, business and IT are coming together. They're working side by side. We can't do it without the business being involved, and the CEO, CIO. It has to come from the top of the house, because these digital transformations and this move to the cloud, yes, there's a technology component to it, but it involves a significant organizational change and how they're doing things. And if if someone's doing organizational change and changing the way their organization works and they're not experiencing excruciating pain, they're probably not doing it right. So it does involve the CEO, the CIO, all of the C-level leadership they have to be stakeholders, and they have to want this. Have to want this badly.
That's great. Thank you for your answer. Thank you for your presentation. It's been great to have you here.